Welcome, everyone, to Soil Building and Cover Crops with Seed St. Louis. I am Dean Gunderson, the Director of Education here at Seed. And we are going to get going because this is a big topic that I am really passionate about. And so I'm worried that I'm going to go over it. So I'm going to do my best not to do that. So first, I'm just going to jump right into what soil is, which seems like a pretty basic thing, but it maybe is a little more complicated than you thought, although not anything too crazy. So generally, when people think of soil, they are thinking of the mineral component. Like usually when somebody says, what's your soil like? Or what's your soil type? Or something like that, what they are really talking about is just the mineral component. So there are three main kind of particle sizes is really kind of what that breaks down to. There's sands, there's silts, and there's clay. So clay are the smallest particles, sand is the largest particles, silt is in the middle. Anything larger than sand we would call a rock, and there really isn't much smaller than clay. And depending on that size of particle and the blending between them that you have depends on what soil type you have, whether it's a clay soil or a loam soil or a sandy loam or a sandy clay or a silty clay. That's just a reference of what is the blend of those three particle sizes that make up the mineral component of your soil. And there's these charts that people have made to tell you that. So if it's 100% just stuff in the silt category, you have a silt soil. But if you have something that's 60% silt, or no, 30 to 40% silt, and like 60 to 70% clay, then you have a silty clay loam. And so there's all those different things. So that's when people say those terms, that's all they're talking about is what is the blend of those particle sizes that make up the mineral point part of your soil. So that mineral point is like the non-living things. It is like the rock material that makes up your soil, because ultimately sand, silts, and clays are just small bits of rock is what they are in the grand scheme of things. So this mixture is mostly out of your control. What that mixture is tends to be a result of the geological past of your garden, your orchard, your location, the climatological features that you're dealing with. So like how hot is it? How dry is it? Hotter areas tend to have more clay soils a lot of times because it can kind of burn off some of these other materials. And also past use factors. So especially in our urban environments, the soils tend to be more clay because construction workers like clay. Clay is easier to pack around foundations. You don't get as much settling. You don't get as much shifting. And so they tend to scrape away the stuff that is higher quality and sell it and leave more clay material. So in developed landscapes, the soil is going to be very different than it would be if that exact same piece of land had not been developed. So those geological, climatological, and kind of past use factors are not something that you can control. And it's practically impossible to change your type on any sort of scale. If you're like, I want an acre garden and I want it to be more sandy, you would need to bring in like dump truck after dump truck after dump truck of sand and then somehow mix that in to like make it more sandy. And that's just a lot of work. I mean, 1 cubic foot of soil, like the mineral component of soil, is 80 pounds. So, I mean, we are talking about literal tons if you're wanting to convert any large scale change to your soil type. So you're kind of stuck with that mineral component for the most part. The exception to that is container gardening or raised bed gardening, where you are just hauling in the soil. So you can pick what that soil is that you are buying in and making like a big container of. And so you do have some control there. And generally speaking, what people find the best are these ones in the middle, the kind of even blends. So loams, so things that have kind of a nice mix of silt, sand, and clay, but less clay. So pore space, doesn't it's the negative space is also an important part of your soil. If you have no pore space, you don't really have soil because nothing can grow because the roots, the water, everything lives in that pore space. So it is simply the open space between those mineral particles. It's also where the organic matter lives and where the living organisms live in the soil is in that pore space. Ideally, you should pore space should make up about 50% of the volume of a soil. This is regardless of soil type. Clay soil pores are just smaller. Sand pores are larger because the particle size is larger. And the fact that it's smaller is also why clay soils tend to hold water longer, is because it takes longer for the water to kind of drain through those small pores, and there's more surface tension and different stuff going on. If you have less than 50% pore space in your soil, it means you have compaction. That's just kind of the definition. And I'm just kind of running through some general ideas here. I know these aren't necessarily actionable items. But then there's also organic matter. So organic matter is the living or formally living material in your soil. So this is not the mineral component. These are not small rocks. These are the things that used to be alive or are currently alive. This generally makes up about 2 to 5% of the soil from a weight standpoint. But it can vary widely. Some soils, especially if they've been very highly degraded, have almost none. Rich, old growth forest soils can be ridiculously high in organic matter. It can vary. And organic matter, that piece of your soil, about 30 to 50% of that is stabilized organic matter. So this is what humus is. If you ever hear people talking about like the humus in the soil, that's the 30 to 50% of the organic matter that is pretty stable, as in like kind of no matter what you do, not no matter what you do, but for the most part, it's not going to quickly break down. It's not going to quickly off gas into the atmosphere if it's tilled, which is what happens with the decomposing organic matter. When you till your soil, most of that decomposing organic matter is going to be eaten up by bacteria really quickly, and it's just going to go right into the atmosphere as CO2. About less than 10% of the organic matter is fresh residue. So these would be things like the dead material that is like still recognizable. Like you can tell like, oh, that was a leaf, that was a stick, that was a root. And then less than 5% of the organic matter is living organisms. So, this is 0.1% to 0.25% of the soil are living organisms. But we're actually going to spend a lot of time talking about that ridiculously small percentage because it turns out it's a pretty important part. So these living organisms, that's 0.1 to 0.25% of the soil, is surprisingly important as we are finding out, or as researchers are finding out. And generally speaking, the higher the percentage of your soil that is made up of these organisms, mostly microorganisms like bacteria and fungi, protozoa, nematodes that you see listed there at the bottom of the slide, the higher the percentage of the soil that is those things, generally the higher your yield and the more productive the soil. Some old growth forest soils have been measured to be 70% fungi by weight, which is wild because fungi is not heavy. You hold a mushroom, it is not a heavy thing. And the soil is 70% fungi by weight in some old growth forests, which are pretty productive landscapes. There's a lot of biomass going on there. And research is finding that it can have a huge influence on soil properties as well. So like the way that the soil acts can be impacted by those soil organisms. And this work was primarily pioneered by Dr. Elaine Ingham, but there has been a growing number of researchers that have been doing this work. It is not just Dr. Ingham who is doing this anymore. And the organisms of the soil include things like bacteria, fungi, protozoa, nematodes, microarthropods, and then some larger things that we would recognize like earthworms, burrowing rodents, things like that. But for the most part, what we're talking about is these microorganisms today. So I want to kind of throw out kind of a general view of the soil, and maybe this is not everyone's experience, but my experience, and when I read most documents, this is kind of the idea about soil. That I should be, based on this is what you should do, is generally what you're going to find. So the ideas are the mineral component of soil determines the soil structure and how well it holds water or drains water, which is called infiltration. Pore space, or lack thereof, determines the water holding capacity of the soil and the rooting depth, how deep the roots can go. Organic matter improves structure. So adding organic matter, adding compost improves the structure of the soil. It improves water holding capacity and acts as a fertilizer for the plant. Soil organisms are mostly diseases, and a few that have some benefits like earthworms. And soluble nutrients need to be added regularly in the form of fertilizers, whether those be synthetic, organic, or biological. I could be wrong, but I'm imagining most of you that all kind of rings true to what you hear people talking about. And I'm not saying that all of those things are wrong, but I'm just to lay out that that's kind of the common view of soils. And based on those common views, generally speaking, the recommendations are you need to do a soil test to find what nutrients you need to add to your soil. You need to do a pH test to figure out what minerals you need to add so that that pH will get into the right range that you want. You need to do an infiltration test to find out if you need to increase pore space through things like tillage, plowing, adding organic matter. And you need to add organic matter, so things like compost and or fertilizers on a regular basis to replace nutrients that are being removed when you remove the plant and eat it. So that's kind of the general story of soil as I have experienced it. But there's a couple problems with that. If you start actually like living with these things and you start like looking at things and trying to test them, many of those things are not incorrect. But there's a couple kind of holes in that where you're like, that doesn't quite explain why this is happening. And some of those things are things that like soil that are the same soil type. Like you can look on soil maps, the same soil type can look radically different and can change in the way that they look when they are under different management practices. So it's probably not just that mineral component. Infiltration rates can be drastically different in the same soil type under different management practices. And manually aerating your soil, so that would be things like using a tiller or a rototiller or a plow, doesn't increase infiltration rate for any real length of time. If you like, and you've maybe experienced this, you till your soil, you water it, the water soaks in, but by the end of the year, it's not really soaking in like it did at the beginning. It doesn't kind of hold. And an example of this too that I like to point out is, so this bowl right here are 2 soil tests that I pulled off of some family property. These are, if you look at them, these are the exact same soil type, and they used to look exactly the same, and they were under the exact same farm management for like 150 years about. And then the soil test that was pulled here, this area, about 5 years before this soil test was taken, was just kind of stopped farming and was mowed once or twice a year. And then some bushes and things were planted into it. And you can see in here that, you know, just in those couple years, the soil color is different. But the big change was that an infiltration test was done to see how quickly water soaks into the soil, was done at both of the sites that these were taken. This site over here soaked in water at a rate of 1/15 of an inch an hour. So in 1 hour, 1/15 of an inch of water soaked into the soil. This over here, which again is the same soil type, infiltrated 1 inch of water in 11 seconds. So that tells me that the mineral component is not the only thing determining the soil's behavior. Because obviously, like, this is the same soil type. They looked exactly the same. The management was changed here, and the infiltration rate went from 1/15 of an inch in an hour to 1 inch in 11 seconds. That's a huge difference. And also there's some studies that are being done that are finding things that like soluble nutrient concentrations, which is the number that you get if you do a soil test. Like when you get a soil test and they say you have this much phosphorus, that is not telling you how much phosphorus is in the soil, that is actually in the mineral components. It's telling you how much is in a liquid form, basically, in the soil. So how much is actually like directly absorbable by the plant. So those soluble nutrient concentrations aren't actually correlated with yield very much. There's been some greenhouse tests that have been done, and they'll do correlations between yield and looking at like the NPK levels in the soil, and they find that there's only a 5% correlation between those fertilizer levels in the soil and yield, compared to an 88% yield correlation between those yield levels and the fungal to bacterial ratio in the soil. And we'll talk about what that is exactly, but it's a measure of the soil microorganisms. And also another thing that maybe points to these organisms in the soil being maybe important is that plants are actually putting an enormous amount of what are called exudates, which is like the sugars and things that they're producing, not into their own bodies, but they're pushing them out into the soil to do something with. Like they're not using them directly. And so if they're doing that, we should probably wonder why, because like we care about these plants. We want them to be producing food, and they need those sugars to produce food. So if they're just throwing these sugars into the soil, it might be for a good reason. And plants are putting a lot of effort and energy into the soil, like below the soil surface. And this shows you here how much of the total photosynthetic energy, like all the light that's hitting the plant, the energy that they're producing, the sugars, the amino acids, the complex carbohydrates, all those things that they're producing, fats, lipids that they're producing are going somewhere. Like they're producing them in their leaves and then they're moving. They're not all staying in the leaves. They're going to produce branches, new leaves, the stem, the trunk, the roots. But a lot of it, like look at some of these numbers, is going below ground. It's not going above ground. And when they have done tests to try and see, like we can see how much energy is happening, how efficient the photosynthesis is, so you can get like an idea of how much like carbohydrates are being produced in the plant. And a lot of them are missing. They're not in the plant. And they have found that generally speaking, half of the energy that goes below the soil does not stay in the plant. It's going into the soil. It's being released into the soil. And those things, those, carbohydrates, sugars, lipids, amino acids, that's food. That's what that is. That's like those things are not going to like feed rocks. They're going to feed living organisms, like because that's food. That's what those things are. And those are called exudates. And they're simple foods as well. This is another thing. So these are not things that earthworms are eating. They're things that bacteria and fungi are eating. Bacteria and fungi are then eaten by protozoa, nematodes, and then those protozoa and nematodes are eaten by microarthropods, and then those are eaten by other organisms in the soil. And so just like above ground, it turns out that plants are the base of the food web, like the below ground food web. And, based on these numbers back here, if our crops are giving 37 to 42% of all of their energy to these organisms, they're probably important. They're probably important for us to care about if we want to have good soil and we want to have those plants growing in a healthy, happy way so that they produce lots of food for us. So why would plants feed them? Like that's a lot of energy to be giving to these things. They must be getting something. Like they must be doing something important in the soil. And it turns out that they're doing something real important. Several things. One is that they're building structure. Bacteria and fungi create glues, which allow them to stick to these mineral particles, because bacteria and fungi can release acids into their environment, which dissolve, that eat away at these clay particles, these sand particles. They're rocks. They're little itty bits of rock. They can dissolve them, and rocks are minerals. They're high in minerals. So as they're dissolving these, they can then get things like calcium, magnesium, phosphorus, potassium, nitrogen, manganese, sulfur, all these minerals that are in these rocks. They can dissolve and get into their tissue. But to do that, they have to stick to the rock so that when rain comes, they don't just wash away and not have any food anymore. And so they stick. And so if they're stuck to a particle and then another particle comes over and then sticks to it too, then those two particles are kind of one particle now. And that happens over and over again. And it can take these little itty bitty things and make them into kind of aggregates, into kind of larger clumps, which create larger pore spaces. And that those more pore spaces mean that there's more space for water, there's more space for roots, there's more space for more microorganisms to be doing this and breaking down these rocks and these minerals. Creating this pore space helps prevent compaction. That's why, like, if you've ever been in a forest, like a not on the trail, but if you go off trail, which I'm not necessarily recommending, but if you're in like a healthy old forest and you walk on the ground, it's not hard. It's kind of spongy. It's soft. Part of that is the leaf material on the surface, but it's also the soil itself. And if you kind of dig your hand in, you don't usually need a shovel. You can kind of scoop it with your fingers because it's like a spongy texture. And it turns out that that spongy texture is not because it has the magic loam, mineral components all the time, it's because of these fungi creating these structures and these bacteria creating these structures. And this allows the soil to hold more water and also allows oxygen to penetrate more deeply into the soil, which means that roots can go more deeply into the soil because roots need oxygen. They can also like directly actually help suppress disease. There's certain fungi that literally have these like trap structures that will catch disease-causing nematodes, and then they eat them. There's crazy stuff going on in the micro world. And there's also the idea of competitive exclusion. So if there is a healthy, robust population of fungi there, it's going to be harder for a disease-causing fungi that shows up to get established because there's not enough food available, because these like healthy, happy ones that are not causing diseases are eating up all of the food that the plant is releasing. So it's harder for that disease to get established, to grow, and to infect that plant. And also, like I talked about, they're able to dissolve all of these minerals and they incorporate them into their body. And so they're like liberating these materials from these rocks that the plant cannot access for the most part. And so they get these, and then by bringing them into their organic tissues, because they are living organisms, those nutrients then become soluble, which means that if this fungi or this bacteria gets eaten by a nematode, a protozoa, an earthworm, that's actually, earthworms are mostly actually getting their nutrition from bacteria and fungi. And then those organisms poop, that's manure. It's micro manure. And just like a cow's manure or a horse's manure or a rabbit's manure is good fertilizer for your plants, so is a microarthropod's manure, so is a nematode's manure, so is a protozoa's manure. And it's going to fertilize those, and they're living right by the roots. So it's not washing away, it's not getting lost, it's not washing off, the soil surface. It's right there at the roots for the plant to absorb it if that happens. Or there's also organisms, particularly fungi, that we call mycorrhizal fungi, that can actually create a relationship with a plant, and that fungi can go out, break those minerals down, and I mean, they're not literally talking in the way that I'm talking, but basically go to the plant and be like, hey, I got a bunch of extra calcium. I'll give it to you if you give me some sugar and some amino acids. And the plant says, all right, and gives it those materials, and then it gets its calcium. And these fungi networks can also move material from one plant who has more than it needs to another plant who doesn't have enough. There's these really intricate networks that are going on in these undisturbed, healthy soils where these plants are sharing excess materials that they don't need at the time with things that need more materials. And then when this other thing has more than it needs, it shares back, and they're sharing back and forth across this system. And there's some really interesting studies that I don't have time to go into on like how extensive that is, that are really cool. You should look up some mycorrhizal studies if you're interested. So all of this kind of boils down, these microorganisms, like the measurement that is used when people have started doing soil tests, and there's a few places that can do soil tests this way. So instead of looking at like what is the NPK or what is the pH or what is that, like another metric that you can measure is the fungal to bacterial ratio. So bacteria and fungi are better at doing different things, and different species are better at certain things. And different types of plants need different types of organisms to supply them with the nutrients that they need. And this ratio of fungus to bacteria is called the FB, or the fungal to bacterial ratio. And depending on what your soil's fungal to bacterial ratio is, can determine how easily a plant will grow. So so what I mean by all of that is kind of the idea that, bacteria will create, so a big one is nitrogen. Bacteria mostly are creating nitrogen I can never remember which is which, but they create nitrogen in one form, I think nitrate. Fungus, the nitrogen that they are kind of, incorporating into their bodies and then making available to plants is ammonium. So there's these different forms of nitrogen, and different plants like or have a preference for those different forms of nitrogen. And so if your soil is mostly dominated by fungus, then plants that prefer the type of nitrogen that bacteria make are going to have a much harder time growing in that soil than something that prefers the type of nitrogen that fungus make. And so this is one of the reasons why, if you go to a disturbed environment, full sun, there could be, weeds everywhere. You see, foxtail grass and Johnson grass and dandelions and pennycress and henbit and chickweed and, all these different amaranth, lamb's quarters, these things that like disturbed environments. They like bacterially dominated soils. They like the nitrogen that bacteria produce. This is why in these disturbed sites, you see a lot of these things. But if you go to a forest, like a healthy old growth forest, even if you get to a spot where there's a clearing in the forest, like a tree fell over and there's plenty of sun and maybe there's some exposed soil, you don't see amaranth and lamb's quarters and foxtail grass growing all over the place, even though there's nutrients, there's water, there's sun. Why is that? Again, the reason is the fungal to bacterial ratio, it turns out. And plants can actually shift this to some degree to get what they want, because they'll release exudates that encourage the organism that they want more of. And this is just gives you an idea here. So things like weeds can't tolerate mycorrhizal fungi. Mycorrhizal fungi can actually parasitize weeds, but they want like 1 part fungus to 10 parts bacteria, and it gradually goes up. Most of our vegetables want like a 3 to 4 ratio, so about a 1-to-1 is kind of what they're after. All the way up to things, like deciduous trees want a 5-to-1 to 100-to-1, or like coniferous old growth, like out in the Pacific Northwest, have like a 100-to-1 to a 1,000-to-1. So very fungally dominated. So if you want to encourage the health of your vegetables, but you keep doing things to your soil that make the 1-to-10 ratio that weeds like, then you're going to get a lot of weeds, and your vegetables are going to have a harder time growing than the weeds are. But if you get your soil more to a 1-to-1 ratio, your vegetables are going to be extra happy, and the weeds are going to have a harder time growing, is the idea. So then why aren't all soils just phenomenal then? If soil life is so critical and can kind of compensate for mineral differences and pore space issues, then shouldn't all soils be great? I mean, like, this sounds great in theory, but like, why isn't everybody doing this if this isn't if this is a thing? Well, so part of it is that disrupting soil through things like plowing, digging, and especially tillage, which pulverizes the soil, and literally like churns up and slices up things like worms and fungus and microaggregates and basically everything except bacteria. You kill that structure, you wipe out that structure. And I am not sure I've ever seen a piece of land that wasn't, some really important old growth forest that we shouldn't destroy, that hasn't been plowed or bulldozed or excavated or something that has like seriously disrupted that system. And also salt is very toxic to, all life, but to microorganisms in particular. And lo and behold, fertilizers and basically all herbicides, insecticides, pesticides are salts from a chemistry standpoint. Like, they're not like table salt, but salts. And these are toxic to soil life, particularly fungus. Fungus in particular is kind of the most delicate of these microorganisms. Tillage does the most damage to fungus. Herbicides, insecticides, and obviously fungicides do much more damage to fungus than bacteria. Fungus are slower to get reestablished than bacteria. And so when you do things like till or plow or add fertilizer, you are creating the conditions to need more of those. So, if you're like, oh, my soil's doing fine, but I'll add some fertilizer so I get a higher yield. You add some fertilizer, and that fertilizer kills the microorganisms that were turning the mineral component of your soil into nutrients. Then next year you have to add more fertilizers to get the same yield. One study showed applying an herbicide at 1/10 the application rate that was recommended killed 90% of soil fungus with one application. And again, how many places have never been sprayed with anything ever? It's not many. And so the system is like these are not intact systems, is basically the point I'm trying to make here. So this isn't like the soils aren't great, at least partially because these soil microorganisms are not there. They've been killed for one reason or another, and unintentionally. This is not stuff that we knew and we're still learning about. But if you till, apply fertilizers or any sides, even once, you then have to keep doing those things to prevent a drop in yield. So it's a great business plan if you're selling those things, but it's a pretty bad plan to continue the productivity of your soil. So what all this means is then what you're really kind of looking for in terms of a good soil. Like if you want to know, is my soil good or do I need to improve it somehow? So the couple things you're going to look at. One is you can look at mineral profile. There are some soils that are very deficient in certain things. So doing a soil test doesn't hurt. And it will tell you, if you're looking, you're like, oh, you're really low in everything. It could mean that you don't have that mineral, or it could just mean you don't have any of the microorganisms to make that mineral available. But either way, it tells you you don't have it. There's something missing in your soil. Generally speaking, for vegetables and fruit crops, you generally want a pH in the range of 5.5 to 7.5. You want a free draining soil, so something that is not going to pool and hold water. If it is, it means you have pore space, which is a good indication that your soil life is not good. You also are going to want organic matter, regardless. Organic matter is good. It's an important part of the soil. And then ideally, you want a rich diversity of soil microorganisms, and we'll talk about how you do that. But the things that you need to have a rich diversity of soil life is that, they're living beings. So they need water, they need oxygen, they need food, and they need to exist. So, if your soil has been sprayed and plowed into oblivion, they're probably just literally not there. So you need to reintroduce them in some way. So indicators, so that you don't have to go and pay for all of these tests necessarily, but some good general indicators is that a good color, of a really good healthy soil, is about 70% cocoa. So you get a 70% cocoa bar. If your soil looks like that, if that's the color, you probably got really good soil. If it smells like kind of old growth forest soil, like that nice earthy soil smell that everybody kind of intrinsically knows smells good, it's probably good. And those smells are coming from a lot of the materials that the fungus are releasing, create a lot of those smells. And then visible airways. If you pick up the soil and you squish it and it turns to dust, there is no structure there. But if you kind of pick it up and it's kind of crumbly, almost like a cake kind of consistency, kind of spongy, crumbly, when you squish it, it can kind of squeeze and kind of give, it gives a little bit, but then kind of pushes back. Your soil is great. You've got great airways and good soil structure. But you might not have all those things. You probably don't. Almost nobody does. And so working toward that kind of ideal goal, there are a couple things we can do. So again, generally speaking, there is virtually no soil that is missing elements from the standpoint of the mineral components. That doesn't mean they are all available in your soil, but the mineral components are probably all there. So in theory, if you have really good, healthy microorganisms, you probably don't need to fertilize your soil at all. But we probably don't have that. And so especially if you're starting out, if you're trying to get established or start moving your soil toward a healthy situation, soil tests can be helpful. If you see that there's there's nothing of this, then maybe you really do have a deficiency. But yeah, soil life makes insoluble elements available. But some good amendments that you can do if you're looking to just I just want to make sure that I got everything, even if you're theoretically this sounds great, or even if you don't believe it at all. If you're I don't believe that, I want to do it the way that I've always done it, you do you. But some good micronutrient fertilizers that can be helpful for really anyone are things like azomite, which is a really broadly diverse micronutrient rock dust. It's mined out in, I think, Utah. That it's just a good, very broad spectrum kind of micronutrient fertilizer that can be helpful. And kelp is also similar. It has a pretty broad range of micronutrients. So either one of those, azomite or kelp meal, can be a good kind of general thing to add to your soil just to make sure that you got everything. Because soils, especially in urban environments, have been very abused for a long time. It is entirely possible that there are micronutrients missing. So those are some good things that you can add. And then if you want to be adding like a fertilizer, if you're like, my yields are bad, I need them to be higher now, then some good fertilizers that you can get a quick response from that are not damaging to the life in your soil, if you're wanting to try and encourage that life in your soil, are things like this. So humic acids can really help boost the fungus in your soil and provide some different thing. Fish hydrolysate, which is kind of like a fish emulsions, has lots of good things. Blood meal is a great nitrogen fertilizer. Seaweed and kelp meal are good. And then plant meals, so things like alfalfa meal, cottonseed meal, soybean meal, rapeseed meal, which is a canola meal is usually what it's called in the US. Things like that can all be good fertilizers that are not going to be doing damage to the beneficial fungus, bacteria, earthworms, all those things in your soil. pH range is one that is generally not a problem unless you are trying to grow something with a very specific pH need. In the St. Louis area, at least, our soil is pretty neutral. It's generally, between 6 and kind of 7.1 or 2, which is pretty good for most things. Most things will grow fine there. And again, theoretically, in the long term, fungi in particular release acids which do lower soil pH over time. This is why pine trees, which like coniferous trees, want very highly fungally dominated soil. If you remember, this is actually why pine trees are known to reduce the soil pH, like make soils more acidic. It is not the pine needles, I'm sorry to say. There's been studies looking at the pine needles. They don't acidify your soil on their own. But if you plant something underneath your pine tree, it probably is more acidic there, because it's the soil life that the pine tree is feeding that is acidifying the soil. If you are wanting to acidify your soil, so pH range is something that if you're really wanting to grow blueberries or something, you are going to need to change that pH. It's not good enough to just be like, well, I hope the fungus will change it. Like, don't do that. Adjust your pH and then work to improve the soil life. If you need to acidify your soil, which is the most common thing that you would need to do in the St. Louis area, things like cottonseed meal and sulfur are effective ways to acidify your soil. If you need to increase your soil pH, which is not really a thing in St. Louis, but if for some reason it is the thing for you, lime is the most effective way to do that. And not like the fruit lime, but agricultural lime. You can buy it at really any hardware store. It's basically just crushed up limestone. And then, like I mentioned, things that do not acidify the soil, unfortunately, are pine needles, oak leaves, and used coffee grounds. Used coffee grounds is one that people debate about because they're like, coffee is really acidic. And it's like, yes, and all the acid went into your coffee. That's why coffee is not great for your teeth. Like the acid isn't left in the grounds, unfortunately. So if you want to go buy coffee beans and sprinkle them around your plants, that will probably acidify your soil, but it's way cheaper to go buy some sulfur. And then good drainage. The drainage of your soil, there are no crops that I know of, unless you're growing paddy rice or water chestnuts, that don't want good drainage. None of these crops want the soil to be soggy and wet, because what it means when your soil is soggy and wet is it means there's not oxygen, that pore space is filled with water, which means there's not oxygen, which means those roots are not getting oxygen and they will drown, just like any other organism that doesn't live in water will drown. And so this is somewhat out of your control. So generally speaking, if you have an area that's really wet and is pooling water, it's not a good spot for a garden. But if it's a thing where it's just like, oh, it's not pooling water, but it's just a little wetter than I want, it's not draining quite as quickly as I want, doing things like adding organic matter will improve drainage, and then improving your soil life will build structure and improve drainage over time. And again, this is something that I have specifically seen. It's why that infiltration test that I did went from 1/15 of an inch in an hour to 1 inch in 11 seconds, was because that soil life built that structure. So when we're talking about organic matter is great for a lot of things. It's one of the few things that you can kind of almost universally say organic matter is a good idea. So it does improve drainage because organic matter is spongy. So it helps kind of hold pore space open, especially if your soil is not really healthy at that time. It's a great way to kind of artificially open up those pore spaces. It can hold 10 times its weight in water, so it's good at acting as like a sponge where the water stays there so the plants have it, but it's not soggy, like it's not ending up like it's still allowing oxygen to come through. And it does feed plants and soil life. That organic matter can also serve as food for those bacteria, those fungi, those earthworms, those things like that. And you can build soil organic matter several ways. One, and probably the fastest way, is just adding compost, because compost is organic matter. It's 100% organic matter. That's what compost is. So adding compost to your soil is a great way to very quickly increase the organic matter of your content, or the organic matter content of your soil. Cover crops are another big one, which we're going to talk about here. And then mulching is another one that is very underappreciated in the vegetable garden realm, in my experience. So like I mentioned, to also improve your soil life, which is another thing that I am obviously, as I think you can probably tell, I'm very highly recommending. It needs water, so they need water like all living things. So what this means is that during dry spells, water your garden, which hopefully you're already doing. But this also actually includes during the winter. So historically, we didn't really have real long dry spells in the winter, but we are having that now. I think it was a couple of years ago we had like the worst dry spell winter since like 1989 or something like that. And trees died because trees need water in the winter too. Which, like, most people were like, why are my trees dying? It's like, well, because there was a drought 6 months ago, which nobody knew because it was Christmas. So if it's not raining, if it's not snowing, if it's very dry in the winter, and especially if it's above freezing, even though it might seem ridiculous, it is helpful to water your garden, which hopefully will have cover crops in it. For oxygen, oxygen is really important. One, because pathogenic organisms, those disease-causing organisms, don't like oxygen. They want low oxygen environments. So if you keep lots of oxygen in your soil, you're basically putting something in the soil that is poisonous to those disease-causing organisms, which is great because we don't want them. Keeping the soil well oxygenated means that the pathogens cannot grow and proliferate, but beneficial organisms want oxygen. And so that's what we want. So the things that restrict oxygen are compaction, because it reduces pore space. So there's less space for oxygen to kind of move in the soil. And again, waterlogging. If pores are full of water, there is no room for oxygen. So the ways that you improve oxygen into your soil is, this is kind of a one-time thing that you can potentially do if you're trying to build your soil microorganisms, where you are trying to break up compaction that was done. So the basic idea is to physically break up that compaction and then add organic matter to hold those pore spaces open. So you can do this mechanically by adding compost to the soil surface, and then either using a broad fork or a digging fork to just break, not like turn up and like smash and pulverize, but just like breaking up, kind of cracking the soil. Or you can use tillage if needed. But generally speaking, if you're going to do this, you're going to want to till and then immediately do these other things, which we'll talk about at the very end, where I'll give you just like a formula of what to do. But there's also biological ways to break up compaction and improve the oxygen in your soil. Cover crops is a great one, which is why we're going to talk about it. And there are many different cover crops options. Some of the best for breaking up compaction are things like tillage radish, which is this plant up here that I'm holding, sunflowers, Sudan grass, and winter rye. And we'll talk about those at the end. And then they need food. These microorganisms need food. Living plant roots are the best source of food. So crops and cover crops, have them growing all year if possible, or as much of the year as possible. And then organic matter can be the food when there are gaps. Whenever you're like, oh, I ripped my summer stuff out and I'm planting my cover crops in those couple weeks, after they're removed, but the next things are, before the cover crops are really growing. The organic matter in the soil is what those organisms are going to survive on. The general rule of thumb is that your soil needs at least 3% organic matter, which is not that high, especially if you're in a raised bed. Like, you've probably already got it, but you want it to be at least 3% organic matter to sustain soil life long term. And mulch is another option. If you're like, cover crops just do not work for me, or they don't work in this specific situation, throw some mulch on the ground and it will serve the same purpose. They can eat and break down that mulch to feed themselves until the next plant roots come along. And so like we've talked about, though, there are different, like if you're doing an orchard, they want a different fungal to bacterial ratio than like your vegetable garden. So there are some different things that you would do, and this is kind of the only time I'm going to talk about these differences, because for the most part, the general rules are the same. But if you are trying to increase fungus, if your problem is that like there's a lot of bacteria in my soil and not a lot of fungus, and one of the main ways you can tell that is like, are these weeds growing? Like if you're getting a lot of those like annual fast growing weeds, it probably means there's not a lot of fungus in your soil. If you're having things like, again, foxtail grass, chickweed, henbit, amaranth, lamb's quarters, if those things are growing and keep growing and growing fast in your soil, probably means you need more fungus, or at least you don't have a lot of fungus. So if you're trying to increase fungus, you want to be doing things like mulching with wood chips, dead leaves, or straw, things that are really high in lignin and cellulose, which can only be broken down by fungus. And you want to cover crop with grains like rye or Sudan grass. You want to fertilize with liquid fish. You can inoculate wood mulch with mushrooms, which will, like things like King Strophoria. And you can plant spreading woody perennials under trees, which are also going to help increase the fungal situation. So woody perennials, that would be things, like sage or oregano, thyme. And then if the plants want a bacterially dominated soil, so this is pretty much just things like brassicas, mustard family, and asparagus, then you want to mulch with weeds. All those weeds you're pulling out, those make great mulches for your brassicas, your mustard family, and your asparagus. They will love that as a mulch. And you want to be cover cropping with things like brassicas and mustards, things like radishes or broadleaf mustards. Fertilize with blood meal and add bacterially dominated compost. And then last, for like these pieces of a healthy soil, the soil life has to be there. You could have all the oxygen, water, and food in the world, but if the life was completely wiped out by past management practices, it doesn't matter. They have to be there to take advantage of that oxygen, water, and food. And so if your soil has been tilled, had fertilizer, herbicides, pesticides applied, you are probably going to see a benefit by inoculating your soil with beneficial organisms. And so how do you do that? So we have a whole class on composting, which goes into some more specific details of that, because the general rule, you're going to get it from compost and compost extracts. And so ideally compost that has been made from a diverse stream of things. So not just like I threw all my leaves in a pile from this one species of tree, but like as many different plant materials as possible, because ultimately these microorganisms in your compost are coming from the plants that are composting. And different organisms live on different plants. So getting lots of different plant material together, letting it compost, and then applying that compost to your soil is going to be a great way to do it. Or just compost from different people. Like if you compost and your neighbor composts and somebody down the road composts that grab a little handful from all of your friends and you can swap them around, and you're going to get more diversity in that mix than if you're just making your own compost. And then spread that compost. You don't need much, like real thin, because it's just an inoculant. And at this point, like when we're talking about adding soil life, or you can make a compost extract. So this right here, so this is a bag. You can buy these. They're like compost extract bags. And you put some compost in there and you literally just sit it in the water and you like massage it and rub it and kind of force the water in and out of it. And all the microorganisms will get like kind of dislodged and go into the water, along with a lot of the humic and fulvic acids. Like that's this color. There's no compost in here. This is just the water soluble things from the compost that have come out from like a nice rich compost. And then you put that in a watering can and you sprinkle it on your beds, and that's going to inoculate your soil for you. All right, so then cover crops. So that was a lot, and I'm going to summarize it at the end. But I want to go through cover crops real quick here, because they're not super complicated. I want to answer all your questions, but I think I can get through them quick. But these are important. As you saw, I kept mentioning cover crops as like cover crops can do this and this and this and this and this for when we're talking about improving your soil. So what a cover crop is a plant that is grown for the protection and or enrichment of the soil. This is not something that you are growing to eat or to harvest. It is something that you are growing for the benefit of the soil. Cover crops are, quote, killed on the surface or incorporated into the soil before they mature. That's kind of another distinguishing factor. If you let the plant mature all the way, it's not usually a cover crop. That's then just a crop. So benefits of cover crops. So cover crops can do various things. You can see this big old long list here. They can potentially do lots of things. They can be really beneficial in your garden. And one of the reasons and one of the ways, if you look at a lot of these things it's saying they're doing are things that soil microorganisms are also doing based on what I just told you. And so a lot of this, the way that they're doing this is that they're keeping those microorganisms alive over the winter. Whenever a lot of times they would kind of die off if your soil is just bare over the winter. So they're providing a lot of these benefits through their mobilization and their enhancement of these beneficial microorganisms. But then what to plant? If you look, there are so many cover crops, so many different people promoting different cover crops. Generally speaking, I'm going to say it depends on two things. So what you pick depends on what your goals are, like what you're hoping that cover crop will do, and then what season you're growing it. Just like, vegetables have different seasons, cover crops have different seasons. So in terms of what your goals are, so if you want your cover crop to be providing mulch or be providing organic matter to your soil, like if that's like a primary concern, then you want a cover crop that is going to grow a lot of material, that produces a lot of biomass, that gets big fast, that has a lot of leafy stuff, because that's where that organic matter is going to come from. If your goal is like, oh, I've got some compaction that I want to break up and I want to use a cover crop to do it, then you probably don't want a cover crop with little tiny wimpy roots. You want one with big roots that go deep so that they can push through and break up that compaction. And then, like I said, cover crops are basically the same as vegetables in terms of their seasons. So if you're wanting a cover crop in spring, summer, fall, or like to grow over the winter, you're going to need one that grows during that time. Just like, you wouldn't plant a tomato in October and hope that it overwinters. You're not going to plant a sunflower as a cover crop in October and hope that it overwinters. It's not going to work. So here's the master chart here. And again, this will be posted so you can go back and watch the video and pause it. But this is the master chart of kind of the ones that I have found I really like for various reasons in kind of a small scale garden situation. So for spring and fall, and by fall I mean winter kill, so things that you would plant, they would survive some cold, but they're not going to overwinter. Oats are probably the best one that produces like a lot of biomass. It's because it produces so much biomass, it also tends to be good for weed suppression. And oats, for whatever reason, also seem to be really beneficial for soil life. There's a plant called Phacelia, I'm probably pronouncing that wrong, that produces lots of flowers that is really good for attracting beneficial insects. Peas are a good one that are a nitrogen fixer, so a good option if your goal is to add some nitrogen to your soil. Berseem clover is a good one that adds nitrogen to your soil, and also has flowers that beneficial insects like. And then tillage radish is a great one for breaking up soil compaction and is also pretty good at weed suppression. In the summer, there's really only two that I really like. So those are cowpeas, which are great for nitrogen fixation, and also for suppressing weeds. And then buckwheat, which is good for beneficial insects. It is the fastest growing one. So if you just have a short window in the summer, it's a good one. And does also do pretty well at suppressing weeds. There are lots of other summer ones, a lot of grasses, things like sorghum, Sudan grass, but I'll talk on the next slide why I didn't mention them here. And then for overwintering, if you're wanting something to grow over the winter, cover your soil all winter long, winter rye, also called cereal rye, is a great one that produces lots of biomass, good at weed suppression. Crimson clover is a good one to add nitrogen and attract beneficial insects. And annual ryegrass is good for weed suppression. It looks more tidy. It looks more like a lawn, and is good for erosion. I'll also mention here, because somebody might mention it, if you look up, most sources will say that annual ryegrass is a winter kill, and that used to be true, but it does not reliably winter kill in St. Louis anymore. Our winters are not cold enough, long enough anymore, and it overwinters very frequently. So if you need something to winter kill, I would not do annual ryegrass, because I have had many gardens that planted it, and then spring came and it was still alive, and they had no means to kill it, and it was not fun. So that is just the list of things that I'm like, I like these. They're relatively good to find, but they're or relatively easy to find, but there are lots of other options. Basically, anything can be a cover crop. It just has to do with how easy they are to manage and what your goals are. So, if your goal is like, I want something in the summer that will produce lots of biomass, break up compaction, add lots of carbon to the soil, Sudan grass is hard to beat. It grows unbelievably fast. You can cut it down and it'll just grow right back to like 10 feet tall. You can do that 2 or 3 times in a summer. It is great at improving your soil structure. But if you want to plant something in the fall, good luck, because it is almost impossible to kill. It's got big, huge roots and plants on it. But if you don't want to plant anything till next spring, go for it, because the winter will kill it. It'll break down in the winter. And then by the time spring rolls around, you can kind of, pull up the big stumps that are left over. And it does really good at improving your soil, but it's really hard to kill. So if you're wanting to plant something in the fall, do not plant Sudan grass. Mustards are sometimes recommended that they can help suppress certain like soil-borne issues. I haven't had experience with that, but I know some people really like them for that. And then sunflowers are like a great summer cover crop for supporting beneficial insects. But again, if you want to plant something in the fall, sunflowers leave kind of those big stumps that you're going to have to like dig out or cut off or do something that are just a little harder to manage. So there's lots of options out there. These are just the ones that we have found are relatively easy to manage and work in a small space. So planting cover crops is just like planting basically anything else from a seed. So you weed the area, kind of clear it of debris, add some compost if you have compost available. This is usually when I like to like broad fork the garden, kind of break up any compaction that happened over the season if I need to, or with a digging fork. So not tilling, not turning the soil, but just kind of loosening, lifting, and cracking it. And then I'll rake the soil to kind of smooth it out a little bit, and then I'll plant it. I usually broadcast, so you're literally just like this, old drawing here. You're just kind of like sprinkling seeds around in the soil surface, or you can, literally plant it in rows like you would with vegetables, and then you just water it. For a cover crop, I usually like to throw a little bit of light mulch on top, just to try and keep birds away, especially if I broadcasted the seeds and they're kind of sitting on the soil surface. And then you let them grow, and then you got to kill them. That's the other end of cover crops. So the question of when is a big one that a lot of people have, and it depends partially on the method that you choose to kill the cover crop with. So you want to know, when you plant a cover crop, how am I going to grow this? When am I going to grow this? And how am I going to kill it? You want to know that going into it, because that determines when you need to kill it. But a general rule of thumb is you don't want to kill it any later than the start of flowering. If you let rye seed head go and you let it start maturing and then you try and kill it, it's probably still going to mature those seeds and drop it, and then you're going to have rye growing everywhere. And you've kind of like added a weed to your garden. It's not like a real awful weed, but you've added it. So options for killing, one is just cutting at ground level. So this works for most legumes, so things particularly like peas. This works really well for the clovers. The clovers it works too, especially if they're older and they've like started flowering. And buckwheat. So it's just like, they start flowering, you just cut them at the ground, they're dead. So they're easy. And so you don't need to do that until you can wait as long as like right before. Like if you're like, I'm going to plant some stuff here today, cut the cover crop down, plant your stuff right into it. And that's fine. You can like weed the cover crop. So just like treat it as like a weed. So you can just like pull it out of the ground just like you would weeds, and then use it as a mulch or throw it in your compost. And same thing, you can do that up to, right before you would plant. If you're going to till to kill your cover crop, which, as you can probably guess, is not my favorite way of doing it, but if that's your preferred way to do it, you do have to do that at least 2 to 4 weeks before you plant your crop, because when you till this into the soil, it causes an explosion of bacterial growth, and it will start off-gassing lots of stuff. You can have, there's a lot of nitrogen moving into the soil, and so when you plant stuff, it can actually burn those things. So you need to wait 2 to 4 weeks for the bacteria to throw most of the nitrogen up into the air before it's safe to then plant your crops. You can also do a thing called crimping, flattening, tarping. It's called a couple different things. And for that kind of the same thing, you need to do that at least 3 to 4 weeks before planting. But that is because it's about 3 to 4 weeks to make sure that the cover crop is dead. So the flatten and tarp method, and this is kind of the last bit here. So research why you would want to do this, or kind of the benefits of this over tilling or weeding the crop, is that research has shown you get kind of maximum benefits retained with this method. So when you till crops into the soil, there's studies that show that you actually lose most of the nitrogen that would have been added to your soil after about a month and a half, where a lot more of it is retained. And a lot of the carbon that would have been added also gets lost when you till it in. So more of it gets retained with the flatten and tarp method. There's no soil disturbance, so you have less damage to the beneficial microorganisms in the soil. And it produces a huge amount of mulch to suppress weeds going even into the growing season. Ideally, you want to wait until the start of flowering before you do this, but you can do it before then. You just get the most benefits if you're able to wait because there's more plant material. So all this is you are waiting until it starts flowering, ideally, or as long as you can wait, and then you flatten it. So this is me flattening a cover crop. It's hard to see in this picture, but there's a 2x4 that I drilled a hole in on either side. It's got a rope. And so I put my foot on the 2x4 and I just walk it to just smash down the cover crop. And then I just put a tarp over the top of it, or just something that doesn't let light through. You could put cardboard, you could put old carpet, whatever you got that isn't going to let light through, to smother that cover crop. And you wait about 3 weeks, take it off, and if it looks dead, which you can tell because it'll look like straw at that point, you can then just plant right into it. It's great for summer seedlings. So this is flat, there's no weeds, there's a thick layer of mulch. You can just pull it aside, stick your tomato seedling in there, push the mulch back, and your garden is good to go, and it will be weed-free for at least a month after that. All right, so the whole process in terms of building soil, caring for your soil, for like the start of the process, what I recommend is if you've done soil tests or if you've noticed issues, it would probably be good to do a soil test. And if your pH is way out of whack, do something to fix that. Or if you have major nutrient deficiencies, if you're like, I got a soil test and I have like no phosphorus or something, maybe add a little bit of phosphorus. Or if you're like, there's no manganese, maybe add a little bit of manganese. If for no other reason, to get you those nutrients until the soil life is happier and healthier and doing work for you. But if your pH is way off, you want to adjust this now. So your plants are gonna grow as you're building up the quality of your soil. So that's going back to those slides before where you can raise the pH with lime, you can lower it with sulfur, add things like azomite or kelp meal to correct nutrient deficiencies. And then you want to break up compaction, ideally with something like a broad fork or a digging fork, but a tiller will also work. One of the other reasons that I prefer broad forks and digging forks is that they can also break up deeper compaction. Even if you have a big tiller, it's only breaking up like this much of your soil, whereas a broad fork can go 18 inches deep if you get like a big broad fork. So you can break up really deep compaction with a broad fork and a digging fork, versus a tiller, which just does not get that deep. Then you want to make sure that your soil organic matter is up to at least 3%, which again, if it's a garden and you've been adding compost, it probably already is. But basically this means add a good, couple inches of compost to your soil. And or cover crops is also a way to build, or if nothing else, is a great way to maintain organic matter. So if you're starting new soil, add a bunch of compost, and then if you do cover crops long term, that's going to maintain that organic matter. And then plant something. Having plants in the soil are going to maintain that organic matter. They're going to start building the life in the soil, and it's going to start to hold on to nutrients. The nutrients are not going to wash away as much. And then inoculate immediately. If you've got that good compost, ideally a blend of composts or a blend of compost teas from various people, inoculate that like the same day that you're like breaking up compaction. so that they can get in, they can get deep into those big cracks that you made in the soil and start doing their thing. And then for maintenance, make sure there's always food. So, like your goals with your garden for improving soil health and maintaining soil health is you want to make sure there's always food for those soil microorganisms. So, if a crop is not growing, make sure there's a cover crop or mulch on your soil. Don't leave bare soil for weeks and weeks at a time. Your soil is degrading anytime that is happening. Water during droughts, and then use a broad fork or digging fork and a layer of compost to plant into, or minimal disturbance if you're planting seeds. Because I can't tell you, oh yeah, try and plant seeds into this rock hard soil if you're like, if your soil, if you're like still working on improving your soil quality. Like, you can break up the soil, but like tilling everything all the time is not is destructive to the soil health. So cut a row, or add compost. You can plant just directly into compost. I do that a lot of times, and do that to plant. And then when you're needing to break up compaction, again, something like a broad fork or a digging fork is a great option to do that. And you can do that forever. Like, that is not destroying soil life in the way that other soil aeration techniques are. And then if you till, after your initial thing, if you till your soil, if you need to apply an herbicide, an insecticide, synthetic fertilizer, something like that, then restart the process in terms of re-inoculate your soil, break up any compaction that there might be, something like that, just to make sure that you didn't kill something that you really needed. And that is that. That is how you build soil here in St. Louis, in your vegetable garden, orchard, and how you maintain it and use cover crops to do that. So I hope that was helpful. And if you have questions, I would love to hear them.